All right, welcome to Test 2 Review. So we're going to start here at the top. There are some formulas that you may want to make sure you include on your note card. They're going to be very important. All right. Some other things that you might want to include are the rules of exponents and the leading coefficient test. The first problem are questions that involve our rules of exponents. So when we're simplifying an exponential expression, the first thing that we want to do is simplify inside the parentheses. So we have here the first parentheses. I'm going to simplify that the x's and the y's, I'm going to bring them together. So let's try that. We have the 2 stays on the top, x cubed over x to the 4th. Since the 4 is bigger than the 3 subtracts into the 4. 4 minus 3 is 1. You don't need to write that one, I'm just writing it. Then here, if you want to bring the negative down, you can. So that'd be y to the 6th, y to the 1st. But then you can bring the y's together. We have 2 over x, y to the 7th, all to the negative first power. So the only thing we did there was simplify inside the parentheses. We're going to do the same thing on the second set of parentheses, so the 8 stays on top. We're going to bring that x to the negative 4th down. Y to the 8th over y to the 3rd is y to the 5th on top in the numerator. And then I can bring those x's together. 8 y to the 5th over x to the 5th, and that is all to the second power. So after I simplify inside the parentheses, I want to distribute the exponents. Now one thing that we need to know is we really don't like having a negative there. So because of that, I am going to get rid of the negative by flipping the fraction. So we have here the 2 in the denominator and the x y to the 7th in the numerator. What that does is it changes the negative exponent to a positive exponent. So then after we do that, we can distribute any exponents that aren't negative, because there should be no negatives anymore, through to the parentheses. So we have here x y to the 7th over 2 times 8 squared is 64. Y to the 5th squared is y to the 10th. And x to the 5th squared is x to the 10th. Okay, we combine like terms, so we get here. I'm actually going to just write them kind of by each other so it's easier to read this. We end up with, I'm going to write the constant 64, x, y to the 7th, y to the 10th. Then on the bottom I have 2x to the 10th. 64 divided by 2 is 32. Then on the top, or the x's, I have x over x to the 10th. That gives me x to the 9th in the denominator, y to the 17th in the numerator. And there we go. That is our our exponential expression simplified. All right, the next problem's not as difficult, I think, as the other ones. So we still want to simplify inside my parentheses. This time there's only one parenthesis, so that's kind of nice. I have negative 10 over negative 20. That reduces to 2. X over x cubed. The bigger number's on the bottom, so I'm going to say that's x squared there. And then I'm going to bring my negative up. You don't have to do that step. You can actually subtract the negative 1 from the 4. But I found less mistakes happen when you just bring negatives up and then deal with it. So then inside the parentheses, that simplifies to y to the 5th over 2x squared, all squared. Now my exponent outside my parentheses is positive, so that's nice. So we're going to distribute it through y to the 10th over 2 squared is 4, x squared is x to the 4th. Okay, this is as simplified as we can make it because there's one of each variable, there's no negative exponents, there's no parentheses. So those are our two problems that are exponents. There will probably be an easier one like B on the multiple choice and a harder one on the written section. So let's go to these next questions. It says perform the operation. We want to make sure here that we're just very careful and adding like terms. Okay, so when I'm adding this, I like to just make sure I add like terms. Since I'm adding, I don't need to distribute the plus sign through the parentheses. I can just find my like terms and add them. So 6x cubed y, is there another x cubed y? Yeah, it's right here. So we're going to add those. 6x cubed y plus 9x cubed y is 15x cubed y. Then I have 5x squared y and x squared y, so those are like terms. I'm going to add them. We get plus 6x squared y. And then the negative 7y plus the 6y is minus y. No like terms to combine. Now we've added everything, so we are done. The next problem, problem B here, fairly similar to question A, but there's one thing we need to do first. We need to make sure that if we have a subtraction sign, that we distribute that subtraction sign through. Okay, so what we end up with is the minus needs to go through the entire parentheses. And what it will do is it really just changes each thing's sign. Now, if there was a constant out in front, you would have to distribute that through also along with the minus sign. So the first term changes from a positive to a negative. Negative times a negative is positive. Negative times a negative is positive. And a negative times a positive is negative. Okay, so from there, okay, so we're going to start 5x to the 4th, y to the 4th, y to the 2nd, sorry, minus 3x to the 4th, y to the 2nd. That is 2x to the 4th, y squared. Then I have 6x cubed y and 5x cubed y is 11x cubed y. Then negative 7y plus 6y is minus y. Negative 8x minus 8x is negative 16x. So there we go. Okay, this next problem is a multiplication problem where we have one term times multiple terms. So we're going to distribute that through. So on that first one, we get 42x cubed y to the 5th. And on the second one, we get 35x y to the 7th. And that is our distributing, our multiplication. All right, let's move on to the next page. So the next question is continuing from this multiplication, but instead of one term, we have two terms times two terms, and we just distribute the first term through and distribute the second term through. If it's two terms times two terms, we do have the acronym FOIL, first, outer, inner, last, but that's just a fancy way to say we're distributing every term in the first by every term in the second. So x times 2x is 2x squared. X times 5x is plus x times 5y is 5xy. Negative 3y times 2x is negative 6xy. And negative 3y times positive 5y is negative 15y squared. So then we just combine like terms, and we end up with our final answer. 2x squared minus xy minus 15y squared. Okay, those are the main operations on our polynomials. We add, subtract, or multiply. Now the third operation is division, and we're not dividing yet. Before we learn how to divide polynomials, we have to be able to factor them. So the rest of this section is mostly going to be focused on factoring. All right, so one thing that would be helpful to, especially write on your note sheet, is the roadmap to factoring, kind of knowing what to factor, when and where. That's the hardest part of factoring, is knowing what to do to get started and how do you know you're done. So the first thing you want to do when you're factoring is ask yourself, how many terms do we have? On this first one, there are 4 terms. So when there's 4 terms, a good way to get started is factor by grouping. So we're going to group the first 2 to the last 2. If that doesn't work, we might want to rearrange our terms. If that still doesn't work, we might want to factor 3 to 1. Okay, so this first one, let's factor 2 to 2. Then we will look within each of the groups and say, is there a common factor between the groups? And the answer is yes. The first group, we have a 5a that we can factor out. And in that, we'd be left with x minus 3y. On my second group, we can factor out a positive 2b. If we factor that out, we are left with x minus 3y also. Okay, so then once we do that, we can see, okay, we've got the same binomial in each of my groups. So what we can do is we can factor that binomial out from each of the groups. So if I factor out the x minus 3y from each group, I'm dividing it from this group, and I'm dividing it from this group. So if I divide it from each of the groups, we are left with 5a on the first group and positive 2b on the second group. And that is our final factoring. Okay, question B, we have 3 terms. So we're going to factor using our trinomial rules or trinomial process. So in that case, the first thing we want to do is look for a greatest common factor. In this, there is no greatest common factor, so I don't need to factor it out. So once we do that, we're going to try and look at our first term. It's a 1. So then we're just going to find 2 things that multiply to get to 24 and add to get to 11. And we should get 8 times 3. And they both need to be the same sign, and that sign is positive. So we get x plus 8, x plus 3. And we have this problem factored. That's it. Okay, the next problem, C, 3 terms as well. So let's look to first see if there's a common factor. Let's see, we have 3, 18, and 27. So there is a common factor. So I'm going to factor it out, and we're left here. Okay, now, our trinomial that we are left with happens to be a perfect square trinomial. If you don't see that, that is okay. You can still look for 2 things that multiply to get to 9 and add to get to negative 6. And that would be negative 3 and negative 3. So when you go to factor that, you would end up with x minus 3, x minus 3. But if we ever have a repeated binomial, we really just want to write that binomial squared. Okay. So the other way to do this problem is say, okay, 9's a perfect square. 9 squared, or the square root of 9 is 3. 3 doubled is 6. So you could write that right into the perfect, or the factorization if you wanted to. Okay, a problem where you would actually want to use the rule, though, would be on question D. I would say a question where you have to use the rule. This has only 2 terms. So when we have only 2 terms, we're either using the difference of the squares or the sum and difference of the cubes. D happens to be, let's see, 25x squared and 1 are both perfect squares. So that means we're going to use the rule a squared minus b squared equals a plus b and a minus b. So I figure out what my a is, the square root of 25x squared, or you have to think, what squared is 25? 5. What squared is x squared? That's x. So there's my a. On my b, I don't worry about the negative, and I just think about what squared is 1. That's 1. So when we go and use the formula, we have our a, which is 5x plus 1, and then a, which is 5x minus our b, which is minus 1. And there is the factorization using the difference of the squares. All right. We now have E. I think that E might be one of the harder problems. We have 3 terms, so we're going to factor using our trinomial rules. But the very first thing we need to do is look for that greatest common factor. All right, so we do have the first term is negative, so our GCF will include the negative. Then here I have x squared, x, no x, a bummer, that won't work. But I do have y squared, y cubed. So negative y can be pulled out of this polynomial. Then we are left with 20x squared plus 27xy plus 9y squared. Okay, this is still not pretty. Sometimes when we factor the GCF out, the remaining problem's a piece of cake. This one is still not a piece of cake. So what I want to do is I have a term or a coefficient on my x squared. You can factor this whatever way you want, but I'm going to show you the way I like to do it. I like to take this 20 and multiply the 9. So that gives me negative y times x squared plus 27xy plus 180y squared. Okay, so then what we need to do is we need to go through and we need to find the factors or the things that multiply to get to positive 180 and add to get to 27. So if you want to pause here and try and get those yourself, that's probably a good idea. This is a little bit harder. We have some obvious ones like 18 times 10, but that gives us 28, not 27. So once you get it, you can find that it's 12 and 15. So when we go to factor this, we get negative y times x plus 12y and x plus 15y. All right, we're not done. Because we multiplied by this 20 here, we have to go and balance it back out with our coefficients or constants of the binomial. So we end up having to divide this 20, or this 12 by 20, this 15 by 20. We will reduce it So let's see, the common factor of 12 and 20 is 4. 12 divided by 4 is 3. 20 divided by 4 is 5. On the second one, the common factor between 15 and 20 is 5. So 15 divided by 5 is 3. And 20 divided by 5 is 4. Okay, the last thing that we need to do is bring up the denominators. So we have negative y, 5x plus 3y, 4x plus 3y. And that is our factorization. Then congratulations, we just, I think, did one of the hardest ones on the test review. All right, this next one has only 2 terms, so it's either the difference of the squares or the sum and difference of the cube. Now 64y cubed plus 1 tells us that this is a sum of the cubes. So you'll want to write the sum of the cubes rule down. I think that it's a pretty tricky one, but if I have a cubed plus b cubed, that is equal to a plus b, a squared minus ab plus b squared. So I like to find my a's and my b's first. If I can do that, then this problem is smooth sailing after that. So what cubed gives me 64? That would be 4. And what cube gives me y cubed? That's just y. And b is 1. Okay. So now we have our a and our b. We just plug it right into the formula. A, which is 4y, plus b, which is 1, and then a squared. 4y squared is 16y squared, minus a times b, 4y times 1 is 4y, plus b squared. So 1 squared is 1. And we did it. It's pretty much a plug and go for it situation. That's all you need to do. The hardest part is finding what plugs into the formula. Same idea with g here. So I have 16x to the 4th minus 1. So we end up with 16x to the 4th minus 1. Those are both perfect squares. So it's the perfect square rule again. So I need to find my a, which is 4x squared, and the b, which is 1. So if I plug it into the formula, we get 4x squared plus 1, 4x squared minus 1. Now there is one final step to factoring I actually haven't talked about yet, because that step hasn't occurred until now. And that is just to make sure that all of your factors are prime. This usually will only happen repeated difference of the squares or the difference of the cubes. So we can only use difference, meaning subtraction, of the squares when we have subtraction. So I can't simplify this one further. That is prime. But this factor right here is not prime, which means we can factor it further. It's the difference of the squares again. So we can factor 4x squared is 2x, and 1 is 1. I'm going to write the factors that are prime out in first. I can't do anything with that. And then this 4x squared plus 1 can be factored into 2x plus 1, 2x minus 1. There we go. Okay, on to the next page. We are flying here. We have 6x cubed y minus 15x squared y plus 9xy. So we want to look for a common factor. So there is a common factor of 3, and then x and y. So I'm going to divide that common factor out from each of my terms. So that gives me 2x squared minus 5x plus 3. All right, we have a term on our trinomial that we still need to factor. It's on the x squared, so I'm going to multiply that. I carry my common factor through with me. So I'm going to refactor the problem as x squared minus 5x plus 6. Okay, and then when I factor that, the factors of positive 6 that give me negative 5 are negative 2 and negative 3. So x minus 2, x minus 3. But I can't just leave that there because I did multiply by this 2 here, so I have to go back and divide it out. So I'm going to divide each of my factors by 2. The first one, 2 divided by 2 is 1, so that reduces. I can't reduce this 3/2, so I'm going to bring that 2 up. Okay. So factoring a trinomial when my first term is not a 1 is not always a super intense process. It can be pretty simple when the numbers are smaller. That just gets really tricky when the numbers are pretty big. Okay, I take back everything I said about the other one being the hardest problem. I think this one might be the most tricky. So if I factor question I by grouping, don't write what I'm going to write here. But I just want you to see what happens if I do group 2 to 2 and I factor the x and then I factor the 16 out. I don't have a common binomial between the two. So there's not really much to do there. So, and if I rearrange the term, the same situation is going to happen. We're not going to have common factors to be pulled out. So I am going to factor this a very special way. This isn't a problem that occurs a lot, but it is a factoring that can be done, so I do think we need to be able to see it and try it. I'm going to factor 3 to 1. The first 3 that I factor, I want to be a perfect square trinomial. So that factors into x minus 4 squared. The second one that's individual, just leave it by itself, because what we end up with is a perfect square minus a perfect square, which gives us a squared minus b squared. So my a will be x minus 4, and the b will be 4y. So we end up with x minus 4 plus 4y, x minus 4 minus 4y. And that's the factorization. There's not much we can do on any of these problems. So when you have 4 terms, you factor by grouping. Most of the time we factor by grouping going 2 to 2, but every once in a while there's a case where we factor 3 to 1 and we make the first 3 a perfect square. All right, J, I believe, is our last pure factoring problem. This one is very special because it is a perfect square trinomial. So one thing we want to look for is, okay, so my A and my C, my first and my last term, are perfect squares. If I take 4x and I square, and if I take 3 and I square it, I get 9. If I multiply these together, I get 12 times 2 is 24. It's that middle term. We have a perfect square. So then this factors to x minus 3 squared. So there we go. Kind of nice. You don't have to use this rule. You can factor by taking the 16, multiply the 9, find the perfect factor, the trinomial. You will still get here, but this is a way quicker process if you recognize it in its context. Okay, we're going to move on to the solving for x. This is different than what we were doing previously, because previously we were just factoring, and that's all we needed to do was to factor. But when a problem says solve, that means you need to find the actual values of x. So let's go ahead and try to solve these equations for x. So when I am solving them, the first thing I want to do is factor. I'm going to look for the greatest common factor. There is not a common factor, so then we're going to multiply the 3 by the 14. 14 times 3 is 42, negative 42. All right. And then let's factor this. We end up with, let's see, 2 and 21. So we're going to go x plus 21, x minus 2 equals 0. Now, this is the biggest mistake I see on these problems because we do add in that extra layer of solving, but you do not want to forget to go back and divide your polynomial and finish the factoring the right way. 3x minus 2 equals 0. Okay, so there's our factoring. That's maybe half the points of your problem. Now, actually solving this problem requires us to take each of the factors and set them equal to 0. So if I set x plus 7 equal to 0, we get x equals 7. Then we're going to let 3x minus 2 equals 0. So we add the 2 over and divide by 3. We get x equals 2/3. So those are the two solutions of my polynomial. Now we can check and see if we've done these problems right by simply plugging them in to see if it works or not. All right, next one. Same idea here, maybe a tiny bit harder, or maybe not. We get 2x cubed minus 12x squared plus 16x. Now that x cubed tells us that we should have 3 answers. Okay, so that is a really helpful tool in these problems. So we're going to look for the greatest common factor first. It looks like it will be 2x. So that's x squared minus 6x plus 8 equals 0. And we continue our factoring. Minus 4, x minus 2. Okay, we're going to set each of our factors equal to 0. We're going to say 2x is 0, x minus 4 equals 0, and x minus 2 equals 0. Now, because there is an x here, we have x equals 0 is one of our solutions. If that were just 2 equals 0, then there'd be no solution. Okay. Then we add the 4 over. X equals 4 is another one of the solutions. And then here we add the 2 over. We get x equals 2 is another one of our solutions. So there are the 3 solutions. If we ever have an x out in front of our polynomial like that, 0 will be one of the answers. So there we go. That is solving an equation by factoring. We can also use applications of that. So let's take a look here. some of these application problems. These are technically the same problem. I just wanted you to see them in two different contexts. So the first one says the length of a rectangle is 3 feet longer than the width. If the area of the rectangle is 70 square feet, what is the perimeter of the rectangle? So we have some key information here. We know we have a rectangle, and the length and the width have a relationship. We know the area is 70 square feet, and they want us to find the perimeter. Okay, the reason we ask for the perimeter is so that we can use this on a multiple choice question. All right, so we have here, all right, let's draw a picture. We have a rectangle. We're trying to find the perimeter, so we need to find the width, which we'll call x, and the length. We know that the width, if the width is x, the length is 3 feet longer than the width. So I'm just going to add 3 there. We also know that the area, which is length times width, is equal to 70. So if we take our length and our width and set it equal to 70, we now have an equation set up that we can solve to find x. So I will distribute the x through. We end up with x squared plus 3x minus 70 equals 0. We factor that. X plus 10, x minus 7. And we get x equals negative 10 and 7. But we can't have a negative length because length is always positive or distance is always positive. So that means here that our width is 7 feet. But that's not what the question is asking. The question is asking for the perimeter, which means we also need the length. The length is pretty easy to find. If we know our width is 7, the length is 3 feet longer than that, so that's 10 feet. So our width is 7, our length is 10. That means that our perimeter is 10 plus 7 plus 10 plus 7, or 34 feet. Okay, the next question is similar, but it puts it into real-world context. Your next summer project is going to be making a plan and organize a new pool in the yard. If the area available in the yard is 88 square feet, and the length is 3 feet longer than its width, so we got real creative there. It's the same idea. What would be the perimeter of the pool? So the only difference here is instead of 70, we're just going to replace that with 88. So we distribute, subtract the 88 over, and the factors of 88 are 11 and 8. So that means x is negative 11 and 8. But the negative 11 won't work, so our width is 8 feet. If our width is 8 feet, our length is 3 feet longer than our width, so that's 11 feet. Then to find the perimeter, we know that's 11 and 11 and 8 and 8. So 22 plus 16 is 38 feet. And there you go, that's our final answer. So we actually had to answer the problem further than what we're actually trying to find. but that's an okay thing to do. All right, let's move on to the last page here. Okay, this last page just wants us to use the leading coefficient test. Now, here's the problem with this. This is a multiple choice question. You're matching the graph and the leading coefficient, the graph, the equation, and what's happening on the graph to each other. So you might have to have this leading coefficient test memorized, so it might be something you want to write down. What we have here is it just says state the end behavior of the graph and sketch the end behavior. So the first one, we have a negative leading coefficient and an even degree. When that happens, these end behaviors here are falling. So this is going to fall left and right. And that's all you have to do. You have to match what the end behavior looks like and what's happening here. Okay, on this next one, we have a positive leading coefficient and an odd degree. Those are the two things you need to evaluate. So when that happens, the negatives stay negative and the positives become positive or stay positive. So there it is. There might be more that's happening in between here. I don't know. But I'm just asked to kind of evaluate what the end behavior is. So that means we are going to fall left and rise right. Okay, next one. We have a positive leading coefficient and an even degree. Okay, so that means, I don't know what's happening here, but it doesn't matter. We're worried about these end behaviors. So in that case, we are going to rise left and right. And the last one is we have a negative leading coefficient and an odd degree. So let's see, the negatives are going to become positive and the positives are going to be negative. So that means we are going to rise left and fall right. There we go. So that is our leading coefficient test. It kind of, you just think about what's happening with the graphs. A positive number in front keeps the end behavior the same, what it should be. A negative in front reflects it or flips it. Makes anything that's positive become negative, anything negative become positive. So that's our leading coefficient test, and that is also the end of our Exam 2 test review. Good luck.